Hello my dear students, welcome to one more amazing session from Infinity Lane. This is Suresh, Faculty of Chemistry. How are you all? Hi, Sonali Gope, how are you? Betu is there online. So every day students are coming on regular basis and attending our classes. Welcome to the session. Today we are going to discuss about nucleophilic substitution reactions and elimination together. You all preparing for NEET examination, you have some kind of confusion. You understand what type of mechanism. When the question comes, which mechanism you have to follow. That gives a lot of disturbance and noise in the mind. आज हम चर्चा करने वाले हैं ये सब्स्टिट्यूशन रिएक्शन एलिमिनेशन रिएक्शन का बीच में दोनों कंपटीशन कैसे होगा एंड क्या होगा. हेलो, हाउ आर यू? गुड मॉर्निंग सोनाली, गुड मॉर्निंग. Hi Kaishi, good morning, and those who are online, please like the session, share with your friends and subscribe to Infinity Lane NEET YouTube channel. In the nucleophilic substitution reaction, this is the one we are going to see in the grade 12 in the haloalkanes and haloarenes. And it gives a lot of impact on various types of chemical reactions that need to be presented in this total organic chemistry. So this nucleophilic substitution reaction is very important. It can directly carry you. आज का सेशन के बारे में दो क्वेश्चंस आपका नीट एग्जामिनेशन का आने का संभावना है. So you see, before a slight promotional video slide here, you are preparing for some kind of examination. When you prepare an examination, you need to understand where exactly you stand, where is your improvement area, where you have to develop, and where is your strengthen areas. For that, Infinity Lane NEET channel is going to give you an assessment platform, and this is a NEET test series, and it is an ultimate key to success your NEET, and it is prepared for a grade 11 and 12 and repeaters ko alag bana hua, and it is prepared by the eminent faculties from the NEET YouTube channel, and also it is according to latest NTA pattern, and this is designed in such a way that it is going to give you a real-time simulation of NEET examination. So while everybody in the description box link is available, and you click it and you just explore it. और एक चीज़ है, when you just go through this, you just apply YouTube 30 off. When you apply YouTube 30 off, 30% automatic discount you are going to get. So without delay, I just want to start the session, elimination versus substitution. So what is the meaning of a substitution? What is the meaning of an elimination? And we are going to see detailed version of substitution and elimination, and we are going to see the differences and which conditions substitution and elimination should take place is very important. Substitution means replacement of an atom or a group with another atom or a group. That is called substitution reactions. An example, methyl bromide is taken. Bromine is the atom has to be removed. It will leave from here. So it is called as a leaving group. So this is going to substitute from here to here, so that you are going to get an alcohol. This is nothing but your substitution reaction. Electrophile is a species which is electron deficient and can accept an electron. Sonali, right? Aaj idli nahi kaya. Okay, right. Hi Geeta Madre, hello, how are you? And you see here common leaving groups that you see in the organic chemistry are going to be Cl, Bri, OTS, OMS and OTF. And the leaving ability is I minus is the better leaving group, then Br minus is the better leaving group, then Cl minus, and F minus is the poor leaving group. This is the poor leaving group. And this leaving group reactivity is directly proportional to the leaving group, and this is about the substitution reaction. Let us talk about the elimination reaction. In this elimination reaction, loss of an atom or a group, so that leading to the formation of a multiple bond, that is what is called as a elimination reaction. A tosyl chloride Hinsberg reagent, no, that is different and this is different. Okay, it looks alike. Sonali, so keep asking doubts, and you can see here ethyl bromide you take. This is the leaving group and this is called as the alpha carbon atom. The carbon bearing a leaving group is called alpha carbon, and this is your beta carbon, and the hydrogen attached to the beta carbon is called beta hydrogen. So the beta hydrogen is eliminated in this reaction, so it is called as a beta elimination reaction. ये दोनों eliminate करके a double bond इस तीनों का बीच में form होगा, a pi bond is introduced, and this is called an elimination reaction. You see here leaving a group here and elimination takes place, a new pi bond is formed here, or new pi bond can also be formed. This is not formed because carbon cannot be pentavalent. Here carbon is pentavalent and the new pi bond, this type of bond is formed. Everybody take a pen and a paper, write along with me so that you will understand what exactly the elimination. The previous slide I have given substitution. Now in this slide I have given elimination. Okay, so now let us see various types of substitution reactions and various types of elimination reactions and combination of substitution reaction and elimination reaction. आज का सेशन में आप अनवील करना चाहता हूँ. So 1 hour is yours and you will be out of all the confusions. Stay tuned and do the best. So please एक बार Wurz reaction बता दो ना. Definitely Wurz reaction I am going to tell when the situation demands here. Okay, so keep asking doubts, bachcho. Those who are online, please like the session and share with your friends and subscribe to Infinity Learn NEET YouTube channel. Bachcho, you can see this here, substitution reaction. In that you have two types of substitution reactions, SN1 and SN2. आज हम देखने वाले हैं शुरुआत से SN2. What is a substitution? A replacement of one group with another. And by whom? Nucleophiles say. So classification of the reagent, and 2 here it is a bimolecular reaction when the rate of reaction is equal to K, Rx and the nucleophile. Alkyl halide is a substrate, nucleophile is a reagent, and this is a rate constant, and you are going to see the order is going to be chemical kinetics का हिसाब से ये order 2 होगा, and SN2 or SN2 ही also every point I am going to discuss here. Okay, bachcho, please take a pen and paper, write all these noteworthy points. You will understand this is about SN2 reaction, and let us see the details about the SN2. And this is 1-bromobutane, it is a substrate, and when it is reacted with NaSPH, Na plus SPH minus, it is a nucleophile, and this nucleophile is going to kick this bromine out, so that bromine is leaving a group and this is going to be replaced, and Na plus is going to be a spectator ion which do not actually participate in this reaction, and this substitution reaction, a new group is SPH is replaced over here, so it is going to be nucleophilic substitution reaction, bimolecular reaction. So it is going to be rate is equal to K, Rx and nucleophile. So it is a bimolecular reaction, right, bachcho? And let us see what exactly the importance of this SN2 reaction. Everything I am going to give you in a systematic way. Bimolecular substitution is a concerted mechanism where you are going to see a transition state. A concerted means there is no complete breaking of bond, there is no complete establishment of a new bond, and there will be a situation where an attacking reagent is trying to form a new bond. The leaving group is going to eventually lose its bond. That is a concerted mechanism, and this is a leaving group, and KCN is attack, it is going to give you a CN is there. This is a substitution reaction, double bond ko kuch nahi hoga. It's a concerted mechanism, it is involved. So concerted mechanism means the nucleophile displaces the leaving group in such a way that a single mechanical step and no intermediate are formed. It is done by using an imaginary situation called a transition series. ख्याल में रखो हमेशा ट्रांसलेशन सीरीज आ सकता है SN2 में एक कंसर्टेड मैकेनिज्म, जहां पर कंसर्टेड मैकेनिज्म आ सकता है यहाँ पर ट्रांसलेशन स्टेट होगा या सिंगल स्टेप होगा. एंड दिस इज द reaction coordinate and this is the energy profile diagram. When this nucleophile is trying to make a bond, the leaving group iodine is going to leave this bond, and this is what is called as a transition state, and the reactant, and it is going to be the product, and only one graph is there. This is the energy of the transition state. So concerted mechanisms are single step reaction. Number of peaks is equal to the number of steps, and this much level of subject you don't see in any form of textbooks, you don't see in any form of any online videos. Only Infinity Learn is going to give you the genuine subject, and that can directly you can use in the NEET or whatever the competitive examinations you are preparing it. So never leave this kind of sessions. So please use these sessions for your reference, and please like this session those who are online, and please like this session and share with your friends. इन लोगों को भाई फायदा होना चाहिए, and subscribe to Infinity Learn NEET YouTube channel. And आगे बढ़ना आज stereochemistry of SN2 reaction. If you see, this is the one, and the nucleophile should attack from the back side, पीछे से काटना है, rear side attack, ताकि इसका inversion of the configuration is seen. And the reaction requires the backside attack, and inversion of the stereochemistry in the product is observed. That is known as technically Walden inversion. This is technically known as Walden inversion. You all want to know this and take this in the PDF form. In the Telegram channel, it is given in the PDF form. Everybody can download that notes. Good morning. I am fine. Thank you. Noor, Ashmi, how are you all doing? And this is the stereochemistry of SN2 reaction. Bachcho, yeah. Nurashmi, how are you preparing for your NEET examinations? And 6 months left. So gear up and get into the revision program. 3 types of revisions are there, and we will do a revision in this YouTube channel as well. And everybody stay tuned so that you can do the best in your examination. ठीक है बेटा? And talking about आगे बढ़ना, yeah. I am introvert. Please help me. You're introvert, you're talking about Idli from Madhya Pradesh to YouTube channel Hyderabad, and you say that you're an introvert. No, no, no. So don't say that. You're a very good student. I know that. Talking about when this Br is in this face towards, when CH3S is attacked by SN2, you are going to get inversion. If this is a plus configuration, you are going to see the minus configuration. This is what is called as Walden inversion. This is what is called as a Walden inversion. And if the leaving group is neither on the dash or a wedge, you have 2 options or how to show the inversion. So you can show anyways. This is the leaving group, and whenever OTS is there na, whenever OTS is there na, it do not have any impact on the stereochemistry. When Cl is attacked, you are going to get S configuration is going to get R and S configuration. So you are going to get the same, and it is all depends upon the stereochemistry of this. Moving ahead, if iodine is in the other side, by using an SN2, you are going to get the other side as SCH3. It stays unchanged and it is not formed. And you cannot change this. You cannot change this because reaction is not happening here, isn't it? So you have to change the stereochemistry where reaction is happening. And also moving ahead, the reactivity, if the atom with the leaving group is not chiral, there is no meaningful inversion of the stereochemistry. Say an example, This is not at all stereochemistry specific, it is not chiral. If it is undergo SN2 reaction, there is no change in the stereochemistry. So there are so many myths that you need to know about the inversion of the SN2 reaction. So students usually undergo SN2 reaction, inversion will be given if this compound is having some configuration, बिल्कुल opposite configuration यहाँ पर लिखना है. But the product that you are going to give according to the chirality of the reactive point, otherwise you will be giving a wrong option. So actually NEET examination or any competitive examination focus on the trap or the exceptions. So here no exceptions, traps will be there. Here it is one of the trap that you can see in the NEET examination, but it's very important. And also you see here, so steric hindrances and reactivity of substrates in SN2. One thing I want to say, reactivity of SN2 is inversely proportional to the steric hindrance of the penetration of the nucleophile to attack on the positive charged carbon. So SN2 reactions are sensitive to steric hindrance. जहाँ पर ज़्यादा steric hindrance होगा वहाँ पर SN2 का reactivity भी कम होगा. My name is Dr. Suresh, Faculty of Chemistry from Infinity Land YouTube channel. Okay, right, beta? So you're from Madhya Pradesh, I know. Anush Gope, right? So Radhe. Now you can say methyl iodide and ethyl iodide as the number of carbon atoms are increased. So you are going to increase the bulkiness so that it is going to be less reactive. And you know, it is going to be studied here. So as a bulkiness is increased, reactivity will be less, and bulkiness is decreased, reactivity will be more, very fastest reaction and super slow reaction towards SN2. I'm a doctor, I'm PhD, okay, right, thank you. And this is the order where you can see a question from the NEET examination. Which of the following is least reactive, which of the following is fast reactive, various types of options will be given. To any type of option, this is the simple trick and a tip. So in my class always tricks and tips will be there so that you can do the best. And also we'll see here SN2 favors polar aprotic solvent. So SN2 always favored by polar aprotic solvent and a stronger nucleophile. So the solvent you can say dimethyl sulfoxide, dimethyl formamide, acetonitrile, tetrahydrofuran, and dioxane and dichloromethane. These are all, whenever these solvents are coming, you can say the reaction is going in SN2 pattern. Okay, bacho? Any doubt? Noorasmi? Right. Madhuri, any doubt? Now, one more important factor. SN2 reaction features. So this is the synopsis of the SN2. So there are 6 points I want to say. No, I am not a doctor who can treat, rather I can say a PhD scholar, and I completed my doctorate. Okay, so I am a teacher, I am a chemistry faculty teaching all kinds of competitive examinations, chemistry teaching for since the last 25 years. Okay, so here rate of a reaction is equal to second order K alkyl halide nucleophile. So order is going to be 2, right, beta? And also concerted mechanism. So no intermediate is formed, rather you can see a transition state, and the nucleophile is going to attack from the backside. Inversion of the stereochemistry is seen. That is what is called as a Walden inversion, and works best for primary alkyl halide and secondary alkyl halide. And the leaving groups and need a good nucleophile. A strength of the nucleophile plays a crucial role. Stronger nucleophile favors SN2 and prefers polar aprotic solvent. So solvents दो तरीका होगा, प्रोटिक सॉल्वेंट, अप्रोटिक सॉल्वेंट. बच्चों प्रोटिक सॉल्वेंट जैसे सॉल्वेंट है हाइड्रोजन बॉन्ड कर सकते हैं न्यूक्लियोफाइल के साथ। अप्रोटिक सॉल्वेंट हाइड्रोजन बॉन्ड नहीं कर सकते हैं न्यूक्लियोफाइल के साथ। सो दैट इज द डिफरेंस बिटवीन दिस अप्रोटिक सॉल्वेंट एंड प्रोटिक सॉल्वेंट। एक ही स्लाइड में आपका SN2 का साइनॉप्सिस दिया चुका। एनी डाउट बच्चों? कम ऑन, इफ यू हैव एनी डाउट प्लीज मेंशन इन द चैट बॉक्स सो दैट आई कैन जस्ट शो यू SN1। फिलहाल SN2 दिया आपको, SN2 देना चाहता हूं। सो Madhuri, Noor, Ashmi, and Betu is there in the class. Okay, moving ahead, talking about SN1 reactions. What is substitution nucleophilic and unimolecular? Yes. How many classes you take in one day? I take nearly 6 to 8 classes. For you, you want to join? So just see the Infinity Learn website. It is there in the description box, and you click it and you enroll any course that is available. In many courses I am the faculty teaching the chemistry, so you can come and join with us. Okay, so it is a unimolecular reaction. So rate is equal to K, alkyl halide to the power 1 and a nucleophile to the power 0. So it is going to be unimolecular or first order reaction bachcho, and that is the difference. So SN1, SN2, what is the difference means the reaction kinetics is different. SN2 is second order reaction, SN1 is first order reaction. Understand? Now moving ahead, the details. So tertiary butyl bromide, it is an alkyl halide when it is reacted with water, so it does not influence the rate of reaction. That is the reason why it is a nucleophile. Nucleophile to the power 0 is given, and it is an alkyl halide, it is given into the power 1. If experimentally, if alkyl halide concentration is increased or decreased, rate of the reaction is going to be changed. But if you increase the concentration of nucleophile, decrease the concentration of nucleophile, rate of reaction is not changing. So such type of reactions is said to be first order nucleophilic substitution reaction. So Rx only influences the rate of the reaction. So this is the introduction about SN1 reaction. ठीक है बेटा? Okay बच्चों, let us talk about the one more reaction, mechanism of SN1 reaction. So the solvent is going to start the reaction. So this solvent is going to break this bond, Br is gone out, so the carbocation is going to be formed, and this carbocation is sp2 hybridized, and you see this is a bond line form, and this is going to be complete structure. So this bromine is attracted by this water, so that the bromine is lost. As a result of this, carbocation is formed, it is sp2 hybridized beta. Whenever it is sp2 hybridized, it is a trigonal planar geometry, so that you are going to see the water being an nucleophile, it can attack from this side or it can attack from that other side. You are going to see the formation of an alcohol. This is your final product. Carbocation is important reactions for Z, means carbocation based reactions are important in any format of the examination. So this is the total blueprint of this mechanism of SN1. And the nucleophile concentration, this is the rate determining step. So chemical kinetics is studied here only, so that in that there is no involvement of the solvent. So solvent is going to be initiate the reaction, so concentration of the solvent doesn't make any change. So this is a unimolecular reaction. Yes, you said is carbocation is very important, and in this carbocation has the stability. So you have two types of transition state for every intermediate. Formation of this is a rate determining step, and rate determining step is the slowest step in the mechanism, and it decides the speed of a chemical reaction, and it is going to have two transition states, one carbocation, and you know this carbocation has the ability to rearrange itself. Okay, formation of the carbocation is the redetermining step. Okay, so graph will be given. The graph can tell you the order of a reaction, and it is a two-step reaction. From here to here it is a single step, another one is going to be third step. So number of steps that are involved in the reaction is equal to number of peaks. So we are connected to chemical kinetics in order to study the organic chemistry. So it's very impactful to learn. Simply open the book and by heart the reaction, by heart the reaction. At the end you will end up with a confusion and your freak up when you see the question paper. But you learn the organic chemistry in this way, bacho, you will be having a fighting aptitude to understand the question, so that question will be answered without any error. So marks will be yours and credit goes to you and the Infinity Learn NEET YouTube channel. So you are all dreaming to go into the dream medical college, and let us take an opportunity to help you to go into your dream medical college. Please, those who are online, please like the session. So जहाँ पर कार्बोकैटायन आ जाएगा वहाँ पर rearrangement possible. अगर possible होगा तो हो सकता, अगर possible नहीं होगा तो rearrangement नहीं होगा. There is no rule that every time carbocation should rearrange. You like these sessions? You like this slide? First of all, everybody, एक thumbs up if you like these graphs. Okay, let us continue. So bachcho, moving ahead here, talking about one more example for SN1 here. Cyclohexanol, when it is treated with HBr, it is going to give the SN1 product. So the product I just want to give you here, first HBr is an acid, H plus and Br minus, OH is a poor leaving group, making is a better leaving group by protonating. It's a poor leaving group and is making a better leaving group, and this is going to lose, the carbocation is formed, and this carbocation Br minus is going to attack the final product. And good uncharged leaving groups, it could be Cl, Br, I, OTS, OMS, OTF. The good charged leaving groups, protonated hydroxy group, protonated ether groups, alkyl groups are the poor leaving groups. Fine. हाँ, मध्य प्रदेश से हैलो अल्केन बैंड है. मध्य प्रदेश में हैलो अल्केन हैलो एरिन बैंड है. So give an example where halo alkane you have a regular usage in your life. Anybody can give that? Those who are online, give a regular life usage of halo alkane. Simple question. So try to learn the chemistry in such a way that we are using something which are connected in a regular life, so that you never forget that, right? So it's an open question, anybody can answer this. It's a live interactive session, it is not a recorded session. So in the live interactive session, is not a radio session and a recorded session. So you can interact with us, you can ask any kind of doubts you have and you can discuss the things with us. Right, beta? Fine. Let us see some more content here and some more example. One more example also we can say, another SN1 energy diagram here. The same is given. This nucleophilic substitution reaction part is taken here. Okay. So SN1 reaction is a two-step reaction. So this is your carbocation. So for any intermediate you are going to see two transition series. Okay. Now one more important thing here, let's see. So stereochemistry of SN1. Whenever you have the leaving group, a carbocation is formed. This carbocation is sp2 hybridized. Whenever it is sp2 hybridized, it is going to be trigonal planar geometry. ताकि एक न्यूक्लियोफाइल जो है ना आगे से काटना है पीछे से भी काट सकते हैं. So that you are going to see the product dash and wedged product. So you are going to see the enantiomeric pair. It could be diastereomers also sometime if the other side is changed. And you don't see here, this is the point where you need to understand this racemization and retention takes place in SN1 reaction. So the incoming electrophile nucleophile can attack and the front side as well as the back side, that is the stereochemistry. Now moving ahead, stereochemistry of SN1 reaction you can see. So here it is also chiral center and here is also chiral center. When it is treated with methyl alcohol, this is the attacking place. Stereochemistry of the chiral center can be seen here only. Now it could be a plus as well as a minus, and you are going to see the product as, and this is intact, nothing will happen here. That is the speciality of the stereochemistry. Are you getting or not? So people, students, examination, this is the trap in SN1 reaction and SN2 reaction. That is very, very, very important noteworthy points. ठीक है? Any doubt you can ask us. Moving ahead, SN1 reaction एक ही step में आपको देना चाहता हूँ. So SN1 reaction, it is first order reaction. It forms a carbocationic form so that it has the ability to rearrange itself. And the loss of stereochemistry, racemization can be possible. What is the meaning of racemization? During a chemical reaction, the product is going to form a racemic mixture. So that is optically inactive. Okay. Anuj, so materials are synthesizing the other compounds, the pharmaceutical dyes and plastics. They are crucial intermediates in the production of important chemicals such as insecticide, DDT. Of course, thanks for ChatGPT. Okay, so I am a faculty, I know where the information is coming. You written a very good information about the DDT, and DDT is banned. It is not used now, not used at all. I am asking you to find some useful haloalkane that is used in a regular life, right? So सोच के रहो. So we'll give you the best of the days talking about elimination reaction. फिलहाल substitution देखा भी elimination देखना चाहता हूँ. You have two types of reactions, elimination unimolecular and elimination bimolecular बच्चों. So let us talk about elimination reaction. It is seemingly straightforward reaction. So it is a seemingly straightforward reaction. So if you use this as a tertiary butyl bromide, leaving group is going to be dissociated to form the carbocation. Now if you have the nucleophilic attack over here, you are going to get a nucleophilic substitution reaction. This is the product nucleophilic substitution reaction. चाहे आपको SN1 हो सकता. And if this nucleophile can attract the proton, जब nucleophile कार्बन के साथ काट रहे हैं ना, it is said to be nucleophile. And you are going to see the same species attracting this H, you can say it is a base. So it has a dual role, double role. So a species can be a nucleophile as well as a base. Now this is the place where the students is getting confused. Don't worry, I am going to unveil you all your confusions बच्चों. So मस्ती करने के नहीं, मजाक करने के नहीं बेटा. ऑर्गेनिक केमिस्ट्री रियल टाइम आपका कंफ्यूजन आपके सामने आपको दिखाना चाहता हूं मैं. सो ये कंफ्यूजन से आपका सही कौन सा चीज़ होगा, कौन सा कंडीशन में कौन सा चीज़ पकड़ना है, एवरीथिंग इज एक्सप्लेन्ड हियर. So definitely this session is going to be super awesome for the students, and this is eliminated so that this bond is shifted to gives rise its corresponding alkene. So in this case this is going to be elimination product beta, and this is going to be substitution product beta. Nucleophilic substitution reaction SN1 होगा and this is going to be product is formed by elimination product. So मैं क्या बोलना चाहता हूँ आपको, जब रिएक्शन होता है ना, जब प्रोडक्ट्स बोथ SN1 एंड E1 के साथ होगा, SN2 E2 का साथ होगा, न्यूक्लियोफिलिक सब्स्टिट्यूशन रिएक्शन एंड एलिमिनेशन साथ होगा. कभी कभी एलिमिनेशन प्रोडक्ट मेजर हो सकता, सब्स्टिट्यूशन प्रोडक्ट भी कभी कभी मेजर हो सकता. कौन सा कंडीशन में मेजर आ सकता है एलिमिनेशन को? सिंपल थिंग एक ही वर्ड में आपको देना चाहता हूं, वेन एवर टेम्परेचर इज हाई, एलिमिनेशन इज द प्रोडक्ट. टर्शियरी अल्काइल हैलाइड एनी bulky bases are there, eliminations are the product. If you keep these 2 points in your mind, you can just crack the question in the examination. Dear student, this is a super awesome trick that I can give you. Everybody thumbs up, ek thumbs up and fire emoji. Those who are online, please come on and let's see here. Elimination reaction and temperature is more important beta. And you can see in SN1, 1 mole of this is 1 mole of this. You are going to get 1 mole of the substitution product. And here entropy is not equal to 0 here, while at a higher temperature you see entropy is increasing. So I wanted to say here, I want to say delta G versus temperature, जो एलिंगम ग्राफ जैसे आपको आ सकता है, delta G is equal to delta H minus T delta S. For SN1 is favored at low temperature. If temperature is increased, elimination is favored. That is very, very, very important. So thermodynamics I just want to apply in organic chemistry. So high temperature elimination 1 and low temperature SN1 दोनों product के साथ होगा, because you are going to see the products in the same way. Entropy is increased because number of moles is increased here. Are you getting or not? Bachcho, it's very important. So I can say right now this slide that is visualized to you, no textbook is written here and no online videos, no classroom teaching is available. Only Infinity Learn NEET YouTube channel present this particular slide. I can openly tell you, and take this opportunity as a great opportunity. Definitely you can do this, right? So this graphical explanation is very important. It can be useful for any kind of examination. Moving ahead, example I want to say, this is your 1 bromo 1 methyl cyclopentane. When it is treated with the CH3OH at room temperature always SN reactions hoga. I want to increase the temperature little bit. This is the at room temperature, but it is compared at high temperature. थोड़ा सा heat करो, क्या होगा? It is going to be eliminated, so that you are going to see 2 types of products. एलिमिनेशन, जब एलिमिनेशन होता है सेट ऑफ रोल का हिसाब से प्रोडक्ट देना, ये सेट ऑफ रोल के हिसाब से प्रोडक्ट मेजर प्रोडक्ट होगा. इट इज गोइंग टू बी सुपर ऑसम, it is going to be a super awesome product. And this particular slide, everybody take a screenshot of this. Everybody take a screenshot of this. A long story in a short, at low temperature nucleophilic substitution reaction, at high temperature you are going to see elimination reaction. ठीक है बेटा, any doubt? Now moving ahead, so regioselectivity of E1. So I said this is the product that is formed. This is regioselective, gives the major product. Sage-Jov rule that I want to say here, regioselectivity. During elimination, the product that is formed should be the most substituted alkene. Here you can see this is your tertiary, here tertiary alcohol H2SO4, a carbocation is formed, and this carbocation take this hydrogen A, so that the product A is formed. You can take hydrogen B here, here, दोनों बराबर है, so this is the product. In this product, 2 groups are there with a double bond. In this 3 groups are there. So this is going to be the major product. This is what is called as Shades-of rule. Shades-of rule or Z's-of rule. During an elimination, the product alkene is formed should be most substituted alkene, and this is what is called as a Shades-of rule. And 90% of the 95% of the elimination reactions are beta elimination and follow Shades-of rule. And let's talk about the Hoffman rule later. And Shades-of rule or Shades-of rule दोनों एक ही है. In even reactions tend to make the alkene with this most stable at substituted double bond. This is called regioselectivity of even reaction. And moving ahead, rearrangement in even, yes, carbocation, whenever carbocation is formed, it can rearrange. So this is the one, you can say 2,2-dimethyl cyclohexanol, when it is heated with H2SO4, the product is formed by OH is a poor leaving group, and this OH is a poor leaving group, it is protonated, become a good leaving group, and it is lost as a water to form a carbocation, secondary carbocation, so that this CH3 group that is present here is shifted from here to here, 1,2-methyl shift is formed, so that after 1,2-methyl shift you are going to get a tertiary carbocation become a secondary carbocation become a tertiary carbocation, it is more stable. Bis tris kiss tetra kiss occasionally, and this can undergo deprotonation to give rise a major product according to Shades-of rule or Shades-of rule, and it can be less substituted, and the order of stability, this is more stable than this is more stable than this is more stable, and the more stable stability of alkene is attributed to the hyperconjugation. More number of alpha hydrogens, more is the hyperconjugation, more is the stability. That is also another way to approach the stability of alkene. Fine, bachcho. And moving ahead, if you have any doubts, please let us know. Talking E1 SN2 is completed, SN1 is completed, E1 is completed. Now we are into E2. New center of Sri Chaitanya open in Noida. So congratulations, if you want to join, I will recommend you. मैं सिफारिश करना चाहता हूँ. Sonali, you go and join there. Okay, E2 reaction, elimination by molecular reaction. Okay, right here, whenever this secondary alkyl halide here treated with you see alcohol and sodium alkoxide, whenever this combination is coming, trick, it undergo E2 reaction. You are going to get this product, a new pi bond is formed. So it's again just like SN2 mechanism, like a concerted mechanism. And this is simple E2 reaction. Carbon is having a leaving group is called alpha carbon, and iska bagal wale hai beta carbon hai. So the base, this is your base. Okay, this is your base. What is the base? Base is a species which attract the H plus, which attack the H plus. So this is the H plus, base is going to attack this H plus. So a concerted mechanism के हिसाब से ये bond is, this bond is broken so that a new pi bond is formed. So this is what is called as a elimination by molecular reaction. Okay, so all the conditions that are there for the SN2, it is with E2. Okay, now example you can say here, this is bromocyclopentane, it is a substrate. When potassium tertiary butoxide is there, you are going to attract this hydrogen here to give rise. You can say this is the zoomed version of the structure. Zoomed version of the structure. And this is your beta carbon, this is your beta carbon, and this is a bromine carrying alpha hydrogen. And this base is going to attack any one of the beta hydrogen preference is less hindered hydrogen, so that you are going to take a pi bond. So the product definitely I can write like this. So this is your product. Fine, a new pi bond is being introduced. Any doubt, bacho? Any doubt? That's good. And it requires a strong base. E2 requires, my dear children, SN2 requires strong nucleophile and E2 requires a strong base. Okay? And you can say here, the alkoxides are these strong bases. Any alkoxides. As the bulkiness is increased, the strength of the base increases and their nucleophilicity decreases. And also you can say amides also, you know, lithium diisopropyl amide. It is popularly known as LDA. It is also a very good amide and it is a nucleophile. It is a strong base, not a nucleophile. साबूदाना ओके, सो साबूदाना कहाँ से निकाल सकते हैं? सागोपाम से. सो and base size matters. Small sizes, small bases, methoxide, ethoxide amides, and bulky bases, tertiary butoxide, LDA, DBN, DBU kind of things. And you know, they are sensitive to steric hindrance. Whenever bulky bases are coming, na, you follow Hoffman rule. Whenever small bases are coming, na, you use ZZEV rule. Most of the cases, ZZEV rule only will be followed. Are you getting or not? And moving ahead, example you can say, whenever you use this substrate compared to sodium methoxide is used, tertiary butoxide is used. A bulky base hai na, and a small base. Whenever small base is used, you are going to form a major product, ZZEV product is formed. Whenever bulky base is used, you are going to see the product, less substituted product, Hoffman product is formed. That is the difference between the size of the base does matter. So smaller bases favors ZZEV product, bulky bases favors Hoffman product. It is a very, very important one. It is a very, very important one, bachcho. Madhya Pradesh mein, okay. And I want to give you so many examples of small versus bulky base. And you can see, if it is a small base followed a ZZEV product, more stable alkene, versus Hoffman product, less stable alkene, less substituted alkene rather, I would like to say. And everybody, this is going to be a very important. These 2 points are cut short points, can squeeze the marks from the question paper. You don't leave the marks on the table. You are going to grab the marks in your pocket and take a screenshot of this. Everybody, 3, 2, 1, click it. And you can see here one more. Yeah, E2 reaction is conformation requirement. Super, super important. Advanced questions you can get it from here. I want to say here, this is the carbon and this is your carbon and this is the leaving group and the hydrogen. I want to say the hydrogen and the leaving group must be anti-periplanar, opposite में रहना है, ताकि ये transition state, base is going to form a transition state, a stable transition state to give rise a new pi bond should be formed in this way. And if you see this same example in the molecular basis, if pH, CH3Br, and if you see this beta hydrogen in this way and this bromine and the beta hydrogen looks in the same way, so this elimination is not formed. Rather, it is the only product that can be formed on the other side. Okay. So the product should be formed in this way. So I want to say ATM and CAR, and opposite CMTR you have to use it, CMTR. Okay, so that is CMTR, I'll tell you. And E2 reaction conformation requirement, if you have the cyclohexane, you have the bromine over here and the hydrogen over here, hydrogen over here, hydrogen over here. I have hydrogen atom A, hydrogen atom B, hydrogen atom C, blue color hydrogen, and you have green color hydrogen, Jai Mahakal, and pink color hydrogen. And which hydrogen has to go? Which hydrogen has to go? So I want to say here, this is the same thing can be written here in the other way. You are going to see axial bonds and equatorial bonds. So the leaving group has to be in the axial position to understand the product. So the new product that is formed here, because leaving group, if you take, this is this hydrogen in the equatorial and the methyl groups in the equatorial, and the bromine is in the equatorial, and here bromine is in the equatorial, and leaving group is going to be axial, and hydrogen is going to be in the axial. Okay, in this structure of cyclohexane, bacho, you can say this is axial bond and this is equatorial bond, mind it. And this is your axial bond and this is going to be equatorial bond, for your information. And it is going to be formed, keeping this bromine in the axial is very important. As a result of this, the product formed is going to be like this. So there is no change in the stereochemistry of the methyl group attached there. And I want to show you the predictive model for that. So reagent nature, nucleophile only, and base or the nucleophile only basis, a poor base or a nucleophile. That is the first criteria to decide whether it is nucleophilic substitution reaction or elimination reaction. So there are contradictory things. Nucleophile and the base is always contradictory. So second point is position of the leaving group. It could be a primary alkyl group or secondary alkyl group or tertiary alkyl group. So that can give you the actual picture of mechanism or the determination if exceptions are there. So this is the elimination versus substitution. I already given you the just simple glimpse of this. Whenever high temperature is there, whenever bulky base is there, you just go with elimination, let us see, otherwise substitution only. Okay, Sonali, you want to see the previous slide, you just go ahead with this. It is very important. It is very important. Any doubt? Take a screenshot of this if required. Taken? And this is about the predictive model between SN1 and SN2 and E1 and E2. You can see this reagent का nature क्या पकड़ना है. This is very important. You can say whenever Cl minus, Br minus, I minus cyanides and azides, these are all behaves as just nucleophiles only, phenoxides and carboxylates, because pK is less than 9. And such type of things are there, it behaves as bases only because they have the pKa is greater than 30. Okay, whenever OH minus alkoxides are there, they are going to be a base as well as the nucleophiles. That is the important point. And the other cases, you can say alcohols, water and acids, they are poor bases as well as poor nucleophiles. Often polar protic solvents and H plus donors can be. So whenever these are the reagents, right? Whenever reagents comes now, you will be having first confusion whether they behave like a nucleophile, whether they behave like a base. So this is the overall picture that can tell you. This is the overall picture can tell you. डार्जन प्रोसेस कब होगा? डार्जन रिएक्शंस बिल्कुल SN2 हो सकता है, SNI भी हो सकता है, डिपेंडिंग अपॉन द पीरियड इसमें इस्तेमाल किया नहीं किया. सोनाली, राइट. सो टेक अ स्क्रीनशॉट एवरीबॉडी. सो ज्यादा मेहनत किया आप लोग के लिए ये स्लाइड्स प्रिपेयर करने के लिए. टेक अ स्क्रीनशॉट. 3, 2, 1. And also one more important parameter, the predictive model or ICSE, and this is a single slide can give you sweet answers for the NEET examination. Leaving group position is at for primary, it can undergo SN2, mostly SN2, if not E2. If it is a secondary, it can be SN2 or E2 or SN1 E1 at temperature dependent. If it is a tertiary, it could be either E2, no substitution reaction takes place. And allylic, this is your allylic and benzylic can do either SN1 or SN2, they don't undergo elimination. You can see the secondary allylic and they can follow E1 and E2 reactions if possible. And the tertiary allylic, definitely they prefer elimination. SN2 is impossible. And take a screenshot everybody. This gives you total picture about SN2 versus elimination. Click 3, 2, 1. Predictive model. As I mentioned, you all know about SN1 and SN2. You all know about E1 and E2. When the question paper comes mix matching, you will just take a turn and you leave the actual path. And this kind of examples can give you a super important thing. And also rule of thumb in a chair conformation. This is your chair conformation. Okay, the leaving group must be axial for both SN2 or E2. So this is your axial position. This is your axial position. Okay, so that is the thumb rule. Bacho, we had a very good swell of this, and so many reactions you can do it. And as you are preparing for your NEET examination, it is important to know how you are preparing. So what is your strength areas where you have to improve. For that you need a super important NEET test series proper assessment platform. Infinity Learn is giving you this NEET test series, unlimited key to NEET success. It is for grade 11 and grade 12. Yes, grade 11 and grade 12 and the repeaters. And it is prepared by the eminent faculties in the NEET test series in the Infinity Learn, and it is based on latest NTA examination pattern, bacho, and it simulates the real-time test taking experience. So bacho, don't leave when you just look at this description box. The link is available. You scroll down the link and click it, and you apply YouTube 30 off coupon code, and you can purchase this. So if you apply YouTube 30 off, 30% discount automatically mil jayega. Okay, anyways, we did so much, right? So much good things in today, and next class we are going to talk about nucleophilic addition reactions. Okay, so we are going to study the organic chemistry in the mechanistic approach, and we will do the questions once you completed the mechanism. Hope you all love this session. Please like this session, share with your friends, subscribe to Infinity Learn NEET YouTube channel. Thank you very much. Signing off, Suresh. No problem. Please retract your messages. Betu, thank you very much. God bless you. Those who are online, please like this session, share with your friends, subscribe to Infinity Learn NEET YouTube channel. Thank you very much.